and the conclusion on what are the fundamentals to deploy a lean manufacturing approach. Next module, sorry, by December 17, we'll focus on aerospace factory of the future. I have reshaped a lot this course, which is a course I'm giving in ISAE Super since 6 years. I have reshaped a lot following 2018 because of the growing sustainability concern, which I am quite I would say sensitive to. And I have introduced a big chapter on what I call the sustainable factory, because it's a growing challenge and probably the biggest challenge to all of us as professionals, but also as citizens. So this course by December 17 will take about an hour and a half, a little less probably. Then we'll have a break, and then we'll have it's a case study or a practical exercise. We are not completed with Sophie to work on that, so it's in progress. But basically, what I expect to do is to divide your class in groups of 7 people, approximately, let's say 6 to 8. Each group will be given a role. There will be public roles of, let's say, companies, customers, suppliers. There will be public roles, institutions, citizens. And we will try to make a kind of exercise. So each group will try to propose, let's say, a requirement or an offer, depending his position in the environment, in the ecosystem. And each group will work for 40 minutes on preparing its role. And then each group, one after the other, will come on the stage, on the virtual stage, to present to the audience the result of their work. And we will have, after all the presentation, I hope about a half an hour Q&A to complete the different stage presentation with the different subgroups. Is this clear for you?
Yes.
Perfect.
Yes.
Yes.
Okay, so thanks, and let's jump into the topic now. So first course, just 1 second, I'm trying to close one. Okay, good, that's fine. So first course is on, again, as said, an understanding of this specific sector of aviation. I raise the question of world parts because to a certain extent, it's a specific sector. To many aspects, it's one industrial sector like many others, but I will try to explain what makes it a little bit different from the other. First chapter will be on the customers, ourselves as passengers and the aircraft operators. I will mainly focus on commercial aviation. So aircraft operators will be airlines, but I have a few words on the other aircraft operators, which are the air forces from the countries or the space system companies. Second chapter will be on the suppliers. So this will be more industrial, not really technical, but we'll be talking of what is around industry. And then last chapter will focus on the market trends in this aviation sector. Okay, for the end customer that we are, and that are the airlines, what is an aircraft? If I take the example of an A380, okay, last aircraft will be soon delivered by Airbus, but there are 250 aircraft flying in the world. It's a fantastic aircraft. I had the chance to fly on once some years ago, and it will fly for probably several decades. So I'm sure you will fly on it, and it will pull many MRO businesses, many cabin refurbishments, because a cabin on that kind of aircraft is changed every 8 years as an average. So it's not a dead product from business perspective. So what is this product for the end customers that we are? First, it fulfills a technical function, which is to transport a payload. It's not only passenger, it's also freight, with the necessary safety requirements, of course, And this must be achieved in different conditions of flight. You can have a lot of turbulence, you can have thunderstorms, temperature can be 50 degrees or minus 35. The plane must fly in the right conditions. Then it fulfills a commercial function, of course, with a cabin that needs to be profitable, so the airline can live from this business. And depending the type of market, obviously the cabin will not be organized to deliver the same level of services. If we look at the object, physically speaking, it's a heavy object. In the case of A380, we are talking of a 280 tons aircraft when it's empty weight. And this is approximately split in 60% of that for the structure. So the structure, let's say, is the inert side of the product, and about 40% for the systems. The systems are all the non-inert sub-elements of the product. This includes the engines, but not only, all intelligence, I would say, elements that receive input and deliver output. It can be fluid systems, it can be heating systems, flight controls, and many others. When the aircraft take off, the maximum takeoff load can be the double of these 280 tons. So this means that the aircraft will on board same weight of its empty weight, which will be a combination of fuel, of course, and all the payload, passenger, the luggages, and the freight. In terms of money, it's about $500 million for the catalog price. Obviously, price paid by ANA for the last 3 that they will have received from Airbus, or price paid by Emirates, who has ordered more than 100 ones, are not the same, you may imagine. But it's a big amount of money, and it's approximately split equally between the structural cell, so the 60% of the empty weight, the 4 engines, the power plant, and the other system. So that's interesting to note that the engines are a big part of the price of the aircraft, which means that from cash perspective, and because Airbus or Boeing or the aircraft manufacturers are not making the engines, you may imagine that they will have a supply chain approach to minimize the cash from the engine procurement and to assemble it by the latest time. But we'll come back to it later. Okay, of course it flies, but this is important. This means that unlike a train or a car, it is surrounded with more danger, potential danger, okay? Danger of dropping because of a flying failure, and this would mean danger for transported passengers and goods, but also for the population that would be exposed to a crash. But also it's a danger in terms of what you can see from being above, because an aircraft is flying over territories that can be, well, that in many cases are national territories. And on all national territories, there are safety areas that you don't want some foreign entity to look, to make pictures of, or to approach. So for all these reasons, aviation transportation is a sector that is closely monitored by very important public authorities that are constantly seeking for a zero risk operation. If we look at who those public authorities are, first, as said, they are doing what is necessary to ensure safety of aircraft operations. In France, this is the DGAC. In Europe, it's EASA. In US, it's FAA. In China, there's another one, I don't remember the name. And those are basically giving authorization to fly. And unlike we could imagine, it's not the same everywhere. For example, if you are a French or a US citizen and you have a lot of money, you can buy a helicopter. If you have someone to fly it or you have the pilot license, you can fly it. If you are in China or in India, you're not allowed to fly as a private operator for helicopter. And it's, by the way, the same for many business jets. So the rules of how you give authorization to fly are not the same in all countries and are not given to all parties in the same way. Of course, because of aviation transport being an international service, an international business, there needs to be agreements, and EASA, FAA are ruling a global standard so that international airline can operate, but still there are national and continental rules that are not always the same. The segment of operators of aviation transport is having a professional association, which is IATA, and which has close to 300 members for commercial aviation. So that's the first big important thing. Try to find a business, an international business, where you have hundreds of significant actors. You will have difficulties to find one. Usually it's a couple of dozens, not really more, because of competition. But this is specific to commercial aviation, and you can understand that if tomorrow China was to sell its public airlines to Russia, or if France was to accept that Air France would be sold to, I don't know, Germany, no, many people would disagree on that. So that's the first reason of this fragmented market, is that a national airline is a very important emblem for a country. And this is playing against M&A, against consolidations. There are associations, but there is no big consolidation. Also, depending the market, the financial health of those operators are not the same. It depends on many factors, but also geographic areas. And this is moving with time. 5 years ago, I would have told you, 5 or 8 years ago, I would have told you that military markets were pretty low and that civil markets were earning no money. 4 years ago, I would have told you that civil markets were making a lot of money. And today with COVID, you know where they are, it's very tough. So this is changing with time. And it's not a sector where the business profit is well balanced between all actors. So if we continue to look at the market from the customer perspective, what are the passengers and the airline expecting from what are the expectations from product utilization point of view? Okay, the airline, of course, are pulled by the market evolution, and they are trying to offer the best product so that they follow the market trends. So first, since several decades, they have worked on the fly hour cost. This is obvious, this is simple, by playing on fuel consumption, reducing it, seat density, more seat in an aircraft, aircraft weight, lighter aircraft, better efficiency of the aircraft use, so working on operational performance, on reduced maintenance time, so that the aircraft can fly most of its time. And this has pulled the business activity of the MRO, which are the company delivering, among other, the maintenance services. This has also pulled changes in the aircraft architectures. So this has pushed the emergence of new versions of aircraft, new aircraft, and you have here an illustration of the A350 XWB ultra long range. So extra wide body means large body, big fuselage. That was the A350 that first entered in service in 2015 for Qatar Airways, with start of development in 2008 at Airbus. And on the basis of these new aircraft, completely new aircraft with a lot of composites, so lighter aircraft, several dozens of thousands, several dozens of tons less than similar size aircraft in metallic, thanks to composite. So this aircraft, on the basis of the baseline A350, Airbus has introduced other versions, and the ULR is one version with increased range versus the baseline version, so up to 9,700 nautical miles. Nautical miles is 1,850 meters, so it's close to 2 kilometers. So you can imagine that it can fly to close to 19,000 kilometers. So we can fly from some Western capitals to the closest southeast capital, with of course increased cabin comfort, things that you see, things that you don't see, but that you feel as a physiological comfort, because when you keep seated for 20 hours or so, you may have issues in the comfort of your leg, your back, due to the pressure. So this is a lot of many different technical things that have been developed for such an aircraft. They have worked also, Airbus, on the luggage volume with improved storing of luggage. And also they have worked on more technical topics to have more sustainable aircraft, so reducing the fuel consumptions with more efficient engines, reducing the fuel consumptions with improved aerodynamics, like the end structure of the wings that are called the winglets or sharklets. As you can see on the image, bottom right of the slide, in the older aircraft, the wing was just a flat, slightly curved panel, but now with the winglet or sharklet, you have this nearly vertical edge, which is really improving the small turbulent flow at the end of the wing, and this significantly reduces the drag, improving the fuel consumption. Also working on some reduction of fuel burn in the taxi operation at airport. All the aircraft are using their fuel engines to move on their wheels on the airport, and electric systems to drive the wheel are being developed to be CO2 free system on the airport area. Also working on noise systems. An engine is a big noise problem for inhabitants in cities. So there has been very, very important progresses over the last 2 decades, and there are still new progress coming in, working on the structure of the, let's say, the surrounding of the engine blades, which is a structure using a lot of light materials. And in these light materials, the material companies, together with the aircraft makers and the engine makers, are incorporated technical complex system to basically to create counter waves that are canceling the noise waves from the engine blades. Now, a little closer to the passenger customer that we are all when we are onboarding an aircraft. What are we expecting from this service when we enter the aircraft? Of course, flight time reduction. If we can spend 1 hour and a half to go to Paris, that's better than 2 hours and a half. And that is why you are flying to Paris with a jet, a turbofan aircraft, and not flying with a turboprop like an ATR, because with an ATR you would take about 2 hours. Is this the right question and the right solution, for the coming years, knowing the growing sustainability topic? Maybe not, but we'll discuss that in the December 17 course. So flight time reduction was one improvement. It also has been enabled by increased range. When I was your age and I was flying to South Asia for my summer vacation to backpack there, I usually had 2 stops to go to China or to go to India, for example, because there was no aircraft to fly direct route for more than 5,000 or 6,000 nautical miles. Today, you have direct flights with B787 or A350 or even some A330. Improved cabin comfort. Again, when I was flying when I was taking intercontinental flights 30 years ago, I had no entertainment screen. There was, in the best case, one in the complete cabin. Hopefully you were sitting close, you could watch the only film that was displayed. If not, you had to read or sleep or whatever. I don't even speak of food. It was more a nightmare. And of course, even in first class, you had no flat seat to be able to sleep correctly when you were working one day and working the next day and flying between the 2 days. Also, to reduce price of tickets, there has been the emergence of low-cost airline operators. This is about a 20-year-old segment, not really more, maybe a little less than that, about 20 years. And again, if I take price of tickets you can buy today at a major European low cost to fly to Paris, Berlin, or Amsterdam, or whatever, from Toulouse, the lowest price you can get, definitely, I could not get it in the best case when I was in Toulouse school 30 years ago. Embarking time, I used to come 2 hours ahead of the flight takeoff to the airport. Now you know that you can come 45 minutes. If you like to play, maybe 30 minutes in Toulouse. So this has greatly improved, and many other services in the airport are very, I would say, attractive and efficient. Short video about A350, which is, as said, an aircraft introduced in 2015 in terms of commercial operation with Qatar Airways. There are now about 400 aircraft flying in the world. Airbus has sold close to 1,000 aircraft, so they still have a backlog of 500 aircraft to deliver. And even in the tough present commercial times of post-COVID for the aerospace industry, they still have delivered this year about 40 aircraft, 45, so it's not that bad. Okay, sound is still okay?
Yes.
Yes.
Yeah, it's
Okay.
good.
Yes, thanks.
So moving to the next chapter, aerospace industry. So after a few understanding of the customers, which are in the world of services, now we are in the world of industry. So with actors that are industrial company producing a product and delivering to the next one in a B2B mode. So first, sharing with you a few figures that are important to position the aerospace segment versus the other ones. We are in the world of small series. We are still in the world of series since about 20 years. In the 20th century, it was not the world of series. Aerospace were manufactured like projects are driven in companies working on projects. Company doing bridges, doing buildings, doing events. Thereafter project. One project is different from another one. Until the end of last century, mostly aerospace was driven with the mindset of each aircraft being like a different project. It's a little bit exaggerated, but not that much. Now, since about 2 decades, we're in the world of series. So producing products very similar to each other and trying to organize ourselves so that we can take benefit from repeating one activity for the next product in a similar way as it was completed for the previous product. That's the DNA of serial industry. Still, it's very small series. As you can see on the table, in aerospace, the number of units delivered per day in an average industrial company that are doing aerospace product will be 3, okay? Of course, I'm talking of one product line, okay? So suppose the aerospace industrial company we are discussing is delivering landing tracks, as an example, for commercial aviation. The plant may be delivering 3 landing tracks per day, okay? If you're an automotive company, then we are talking of a plant delivering steering wheels. That was my business for 8 years. The plant is delivering 10,000 steering wheels every day to its car customers. So it's very different from the 3 landing craft than the other companies delivering to Airbus, Boeing, Embraer, or whoever, okay? But the steering wheel company delivering the 10,000 steering wheel a day, it's only 15% of Europe market, 10,000 steering wheel, okay? So this company is probably managing 200 maybe 500, let's say a couple of hundred items that can be component raw materials to manufacture its steering wheel. On the other side, the aerospace player that is delivering the 3 landing craft, sorry, I had difficulties with this one. The 3 landing tracks, this company may manage 10,000 item number. So with that figure, you can understand where are the big numbers and where is the complexity. In the automotive sector, the complexity will come from the volume. 10,000 steering wheel a day. It's one every 8 seconds if you run 24-hour day. So you need to have many tools, organizations, process, methods, equipment to manage a big flow, like a water flow, okay? 3 per day, it's one every 8 hours. It's totally different. But on the other side, managing 10,000 item numbers, you don't do that with an Excel file. You get a headache. 10,000 item number, you don't open the drawings on the table. 200 neither, but when you work on the project, you don't handle the total portfolio of item of the company. You may handle 5%, 10%. But 10% of 10,000, that's 1,000. You don't open 1,000 drawings on the table. You can open 10, not 1,000. Okay, so it's important to have that in mind. And going with that, you have the customization. The 3 landing tracks will not be the same. The 3 aircraft are not the same. In the 10,000 automotive, they are not all the same, but you may have 1,500 steering wheels that are the same for Ford, I don't know which car or whatever. Okay, so in the aerospace segment, one and probably the major specificity of this segment is the importance of product development. I told you for A350, development starts 2008, first entry in service end of 2015, so close to 8 years of development. 8 years with dozens of billion euro. For Airbus, it was close to 15 billion euro. For Stelia Aerospace, one tier supplier, it was $500 million. Among the R&D costs, the factories, the engineers, up to 700 people in the design office. So it's massive. At Hexcel has been developing, is manufacturing the 53% of composite material that are in an A350 aircraft. So it is many tons of composite materials that we deliver to Airbus every day. This is $1 billion investment. As an example, in the 1 billion, you have several composite plants of 250 meter long, no, 500 meter long, several 100 million investment each, highly complex chemical processes to produce a specific carbon fiber that is weaved and impregnated and cured and assembled finally to make the panels. So this is the first important thing: massive investment, massive development challenges. So this is putting a mindset of high technology. Going with that, you have many technical guys, engineers, technicians are key populations in this company. You have a lot of management positions that are driven by technology, and where you can see people with a high technical background. Not only, there are many business profiles, but definitely the engineering, the technical dimension is very important. And last but not least, going with these very complex products, very big product, very long product to develop, you have a kind of emotional link. It's an area where the product passion is very high. In my 11 years in the car industry, none of my colleagues and us in the management team from the different sites I was working on with went to the ceremony, the opening ceremony for a new car launch. In the aerospace, the ceremony for a first flight of a new aircraft, of a new program, is very, very important in the mind of many people. And this is a good illustration of the kind of emotional link with the product. Okay, another dimension of this complexity is in the IT infrastructure. Information technology is used to manage all the data and all the tasks, because when you are working in a company, as long as you have more than one employee, part of the job is to communicate between people, to communicate between functions, between departments, plants, subsidiaries, customers, supplier, and to make that in an efficient manner, you need tools. And the tools supporting communications are, in many cases, information technology tools. Those are designed according to the nature of the object that you want to communicate on. An object can be very various. When you are thinking of a 3D CAD model that is developed in software like Dassault, Katia, or new recent Dassault 3DX solution, this is after creating a shape, a 3D shape, a volume, okay? If you talk other data that are dealing, for example, with business measures, cost, price, you are more in a system that is to, I would say, to transfer order of procuring goods, selling goods, distributing goods, and these are more what we call ERP, for enterprise resource planning. The first family of tools that I explained about, that I explained giving a Katia or Dassault 3DX example, is what we call CAD/CAM tools for computer assist design, computer assist manufacturing. And now I can even take another one. If you want to monitor in an efficient manner all the single second, single unit product data that are necessary or produced at a shop floor machine, like traceability, like statistical process control, like parameter measures, all this is embedded in software applications that are in the family of MES for manufacturing execution systems. Let's take the last one on the graph in the center. PLM stands for Product Lifecycle Management. When a company is delivering a business, they have in the minimum requirement a warranty on that product. In the maximum requirement, going with this warranty, they have a responsibility, to ensure assistance for modification, for adaptation of the product that would be necessary due to change in the regulations or to other kind of reason. Aerospace industry is in this kind of situation. Let me give you an example. September 12, 2001. You probably remember a little, you were younger. Many people remember the day before. But what happened on December 12th? There was aircraft flying everywhere in the world. They had been stopped for a couple of hours, maybe a day, I don't remember very well. But there was an aircraft operator using their aircraft everywhere in the world. And nobody wanted anymore to enable a passenger to enter in the cockpit for any reason without being authorized by the pilot. So there has been an immediate, an urgent demand, an urgent request, from the aviation authorities to change the design solution of the doors, of the cockpit doors, and to replace all the doors of all the cockpit of all aircraft. Well, there's one cockpit per aircraft, but all the doors of all aircraft for all airlines around the world. And this came to all the industrial company in charge of the design of the doors, and to the company in charge of the assembly of the doors on the aircraft, and to the MRO company. So how to do that on an aircraft that you have produced 5, 10, 20, 30 years ago? You need to have all the design stored, archived, updated with all the changes, because there has been other changes in the meantime. And these are tools that we call product lifecycle management. It enables to manage the configuration of the product. That is to say, the split of the detailed definition of each and every product during its manufacture, that is lasting sometimes for a year or more. A big aircraft from start to finish is not far from a year. So managing the changes that may occur within the year of production, managing the changes that may occur during all its lifetime in use. This is PLM. And then you need to communicate with the external world, because the other companies, the third parties, like airworthiness authorities or others, they don't have the same IT systems. They're not doing the same job. So you need interface IT system to be able to share the necessary data with those companies, to be able to drive transactions that you're having with those companies. These are all the blue boxes on my slide. And those are designed to go along with the physical flow, because we must not forget that we are an industrial company. We are talking of companies which first reason to operate is to design, manufacture, and deliver a product. And they do that with design office, with production halls, with logistics systems, warehouses, and transport conditions. So this is the gray boxes. And the more the IT system will be aligned with the physical flow, the more the information flow will keep parallel in the time and in the space with the physical flow, the more efficient the company will be. If you place an order to Mr. Martin and you deliver and you request the product to Mr. Dupont and you pay Mr. Dubois, you may have difficulties. If you order to Mr. Martin, you deliver to Mr. Martin and you invoice to Mr. Martin that will pay you, it might be more simple. Okay, and also if you do that in the same time pocket. We'll come back to it later on. From technology now. The product is complex, the product is big. There are demanding requirements from functional and technical perspective. So you can easily understand that there are complex manufacturing technologies that are necessary, metallic ones, composite ones. There are complex means to manage big dimensions because we are handling parts that are up to 30 meters for the biggest one. And when you are in the world of complex technologies and big dimension, the tolerance, the precision is a key challenge. Why? Because there are always uncertainties. On a machine, the absolute precision does not exist. You don't have any machine that can make 1/100th of a micron precision on each and every operation. This is dreams that don't exist. All machines, depending their type, their nature, their supplier, the technology, are having an intricate precision, an intricate tolerance. And when you are doing big parts, because of the, without going into the detail, because of the precision being impacted by the dimension, then the resulting range of resulting dimension is bigger. So on a 20-meter part or a 10-meter parts, because of the precision of one machine, you may have from one part to another differences on some dimensions that are close to 1 millimeter. And when you want to install a rivet to assemble an aircraft, you cannot have a difference of millimeter. You will make a non-conform part. So this is something very important in our industry, which is that because of the big dimension, we need to have ways to manage a certain recurrence of non-conformities, we call that concessions, that are due to the technological challenge of big dimensions and complex processes. Like you may imagine, the place of human is very important in the shop floor. We have a lot of complex automatic machines, but we have many, many experienced workers that are necessary to assist, to support, to solve some of the technical complex processes that we are operating. And going with this highly skilled population, we have a heritage of, I would say, competence development that is specific to our sector. One example is going with the words. I will make a small switch in French. I'm sure the non-French speakers will be helped by the French speaker one. But all my years in non-aerospace industry, the word to name shop floor employees was workers or operators. In the aerospace industry, at Airbus, at Stelia, at all specific parts companies, you are not talking of operators or workers. You may use the word, but you are really talking of compagnon in the French words. So not ouvrier or opérateur, but compagnon, like compagnonnage. So this companionship is the heritage of this sector, is still used to train a lot of processes. There are processes you can't learn by theory. You can't learn at an external skill. You need to learn by practicing. Training an operator in our industry is something between a couple of months and a couple of years, depending the nature of the job. And I'm talking shop floor. I'm not talking design office or any other more complex jobs. Okay, so this is an important dimension in our DNA. From quality perspective, who are these aerospace players? First, we have an heritage of national companies coming from the defense sector. Most aerospace industries are the heritage of defense product manufacturers at the time of the Second World War. This is the case in Europe, this is the case in Japan, this is the case in the US as well. So we were born after Second World II, or between Second World War and World I and Second World War II. And obviously at the time we were national companies, so hyper-specialized technical culture, doing everything internally, not outsourcing, not subcontracting, a lot of IP restrictions, secret culture. And that's how we first started. And when markets started to grow in the 60s, 70s, there was a first need to grow in volume, in capacity. So we created the first suppliers, but they were more subcontractors. They were more external closed plants with similar capability in one technology that we were sending the pieces of aircraft to, and they were doing the same job under our control, under our procedures, with some, I would say, delocalized, simple computer. So it was really simple subcontracting. And the emergence of supplier came very recently. So in this kind of past way of working, quality was definitely not that of a highly competitive sector with world competition driven by market price and by end customer, like the electronic sector or like the automotive sector are since the 90s or the 80s. Okay, we start to enter in this world since about a decade, but that's very recent. And therefore, the kind of quality that we have with this past and with what I explained in the beginning of this course, the big presence of public institutions that monitor our industry, all this is explaining that our quality is more police quality than total quality. We are more driven by product norms, by I would say a double requirement of how to do and what to do, rather than a total quality mindset inherited from Toyota system. Okay, it is changing. We are progressively coming to total quality, but really moving slowly because the weight of this normative culture is very, very important. So we are entering in lean manufacturing, and we'll discuss again in the second part of today's course, but it's coming slowly. Another important point of the specificities of the industrial players in aerospace is that we are handling big dimensions. So our logistics system, all the systems that manage movement, transport, storage from one place to another of the product are working with these big dimensions. It can be trucks, trains, river boats, sea boats, aircraft. In the Boeing world, in the Airbus world, this is always big dimensions. Because of what I explained previously, of being only recently on a competitive industrial market, our supply chain performance, our flow expertise is less than in other segments. And you can find that with typical indicators like inventory turns. So inventory turn is the time to renew an inventory of a company. So inventory turn in our company is, you can count it on your hands. So 1 to 5, you may find some benchmark players at close to 10 figures in aerospace, but it's very low. So an inventory turn of 1 means that the company has an inventory amount of 1 year revenue. An inventory turn of 50, like a very efficient tier 1 supplier in automotive, means a total inventory of the company that is equivalent to 1/50th of a year, that is a week. So it means a company where the stock between procured goods, work in progress, and finished goods is about a week. That's strong, okay? The time between which you enter what comes from supplier and you deliver what you have manufactured is only a week. So in our business, we are counting that in months. On time delivery, so the adherence in delivering on time any other line, automotive industry, electronic industry, consumer goods, foods distribution, like Carrefour, Auchan, and the other ones. All those, you are higher than 99, 99.5, 99.9. In our industry, we are more in the range of 95. The best suppliers are 99, but you count them just on one hand. And the demanding rules for efficient supply chain, like financial penalties when you deliver late, they are daily applied in automotive or in the food industry, in the electronic industry. In aerospace, it's much less frequent because we are not yet at that time of maturity. Okay, market trends. Quickly, what do we see in this sector of changes, of trends, of evolutions? Okay, first and very important, and again, we will talk of that again in the last course, the Aerospace Factory of the Future. It is an incredible sector with about 5% growth since 2 generations, since more than 2 generations. Since end of World War II, we have increase of activity between 5 and 10%, between 3 and 10%. We have regular crises with world events, geopolitical threats, wars, energy threats, fuel crisis, now COVID ones. But all the time, it has not changed to 5% average growth. Will COVID change it? I will not answer now. We could debate along. We will try to share reflection on that in the last course on December 17. So until COVID, it was a sector with an incredible yearly growth. Second, intracontinental traffic is now operated by low-cost companies. They were not existing 20 years ago, but now they are the major actors in this sector. And third, intercontinental traffic has really accelerated over the last decades, mainly with the entry of new actors coming from emerging countries, mostly Middle East and Southeast Asia. They have an optimized position on the globe, a little bit in between US, Europe, and Asia, which enable them with the modern aircraft to fly without stop from one capital to another. And I will not even comment the price of kerosene, which in some countries is, well, unofficially lower than in others. If we look at the growth for the industrial players, let's take Airbus and Boeing, the 2 big OEM aircraft makers. You have here their volume deliveries over the last 30 years. So you can see that first, the average market has moved from 600 units to 2.5 times this, with close to 1,500 units, no, 1,600 units, yes, so close to 3 times in 30 years. So it's an immediate consequence of the air traffic growth. The previous slide was after air traffic, what we call revenue passenger kilometer. So it's the unit. I'm back on the previous slide. This slide measures the aviation travel unit, RPK. Okay, so it's the average passenger kilometer travel using an aircraft with a 5% yearly increase. And the activity of industrial supplier to this aviation travel market has increased consequently with last year more than 16, no, not last year, in 2018, more than 1,600 aircraft delivered by Boeing and Airbus on the segment of commercial aircraft of more than 100 seats. This has changed first in 2019 with the crisis of the B737 MAX due to some issues in the maneuvering computer assist system, which is pending complete resolution. FAA should pronounce the recertification of the aircraft in a couple of weeks from now. And we all hope this will be the case because it's a real threat to our industry. And the second major disruption to this incredible growth is the COVID crisis. And again, I will come back to it. This tremendous growth has driven an economic competition pushed by the progressive evolution to more total quality system, to more customer orientation. And this has generated the start of low-cost industrial transfers a decade ago, about in the years 2010. And most tier one suppliers to the aerospace industry now have some low-cost plants in their continental closest low-cost region, so Southeast Asia, North Africa, Eastern Europe, Central America, depending where they are located, to have the simple product be manufactured there, and this enabling to reduce the cost of product. The B737 crisis will have put the light on the certification of aircraft, which is the processes that enable an aircraft maker to certify his product as authorized to fly, and this enable an airline to operate the product. So these processes of giving this certificate has been investigated and identified as one of the causes of the 737 MAX crisis. So obviously, in the future, we all know that certification will be more demanding and probably more complex to be gained in order to ensure that such accidents that happened twice on the B737 will not happen again. COVID crisis, where we are. This is the air travel drop by May of the different continental air travel activities. So you can see that it was close to 100% drop by April and May. Only Asia was not as much down. Why? Just because several Asian countries are more experienced in fighting against pandemic, and they were able to quicker handle this pandemic rather than the Western countries. But the drop is massive. Definitely, it is a crisis with an amplitude that we have never lived in aerospace in history, in aviation history. And not only by the amplitude, but also by the duration. And why it will last long, it's because it is a simultaneous pandemic, economic, and geopolitical crisis that affects us. The pandemic measures are reducing the air travel, as you understand, of course. The economic crisis cause of the pandemic crisis will reduce the ability of citizens and companies to expend money for air travel. The confinement measures are also pushing home office and video conference means as a substitution system to travel, to missions, to physically meet customers or your partner. And last but not the least, the general tension between the countries is also placing borderline constraints that are additional barriers to air travel. So with the addition of all these constraints, our assumption today is that the aviation sector will be back to a pre-COVID business volume in a couple of years, not before. And hopefully it will be back. That's a question. Hopefully with a question mark. We can discuss it again, we will discuss in December. Continuing to operate, definitely, it's fundamental, it's a fantastic industry. It's a major asset for any country to have companies able to design, to manufacture, to certify, and to operate aircraft. So we shall definitely support that from all possible ways, with states, with private funds, with corporations, and aerospace industry, believe me, will not die. That's for sure. And I want to be able to continue enjoying working in this fantastic segment. But the question of volume in the future is raised. And that's why I'm putting a question mark of being back at the same volume, okay? But anyway, the drop is massive. We are starting to be back from the drop. We consider the drop was in Q2, Q3, and early Q4 this year, but we think now we are starting to increase back to bigger volume. But in any case, the way back to a bigger volume of air travel will take several years and is expected not before 23, 24. And the way back to bigger volume, maybe same volume as 2019 for aircraft manufacturing growth, I'm saying growth, is in a decade, okay? So should we be back to a 5% air travel yearly increase with the associated increase of aircraft to manufacture? At the moment, we don't see that before the end of the decade. And should we come back at the level of air travel of 2019 and associated aircraft manufactured, so I'm talking of volume but not growth, then we don't see that before 3 or 4 years. And in this way back to bigger volume, there will be a difference between long distance and short distance flights. The long distance one will be the more constrained, will be the one taking the longest time. The short distance will be easier to recover. A few words, catching time, I think we'll end up in a few minutes. A few words on the internationalization of the sector and the modernization of the sector. It started about 20 years ago when Boeing first and Airbus second realized that they couldn't continue to follow the growth with doing everything internally. So they started to externalize, and this created a start of a growth of tier one supplier. In Boeing, they decided to externalize the whole of their aerostructure, so the supplier building the structure of the aircraft. They probably went a little bit too far, and they had to reintegrate some plants because they had difficulties with the 787. Airbus did more or less the same 6 years after, but not externalizing all, keeping some key composite assets, precisely the plants of Nantes, Illescas, and Stade, that are key composite manufacturing plants. And this was to protect the A350 that is using a lot of composite. And more, those OEM for aircraft are concentrating on their core activity, which is the design of the aircraft architecture and the final assembly. In regards to the military market, a few words on that. Military sales around the globe is monitored with several laws, and one of them is offset laws. When a selling country or when a selling party is having business with a country for a military product, then the selling party must give compensations with this military business. And these kinds of law typically explain the Dassault Reliance deal that goes along the sales of 126 Dassault Rafale to India. And this has a little bit influenced the commercial markets with what we call compensation markets. So it's not laws, but it is similar business practice that have started to appear by the end of the 90s with China, and that have grown to big dimensions in the beginning of 21st century in the Middle East, where airlines like Etihad, supported by the Abu Dhabi, Emirates, and UAE, have forced Airbus and Boeing to give big compensation of businesses against the sale of big numbers of aircraft. And this has pushed creation of completely new actors, like two company names on the slide, that were born thanks to technology transfers operated by Airbus and Boeing to enable them enter in the playground of aerospace industrial countries. Other changes in the aircraft industries is that because of the growth and the nice health of this business until last year, there was a lot of companies that were trying to enter in the segment of commercial aircraft of more than 100 seats. It was the case of Bombardier with the C-Series, of Comac with the C919 in China, and it was the case of Embraer in Brazil with the E2-195. I will not make the whole story, but you can just notice that to prevent entry of a third player, Airbus and Boeing have played a certain number of cards, trying to distance Comac with the A320neo and the B737 MAX, to improve the efficiency aircraft to distance Comac with the C919 that would be more seen to comparable to an old A320 or B737. And also Airbus has taken over Bombardier C-Series, now named A220, so they have killed the competitor. Boeing tried to do the same with Embraer, but was prevented to do that because of the COVID crisis. Let's see what comes in the future. So they are trying to compete and to keep in this duopoly, which is of interest to them, as you understand, but which is really a specific case. All those businesses are driven by dollar. It's not a place for euro. There are also big corporations, CFM with GE Snecma, 40-year-old corporation is an example. And also there are a lot of relations with states when it comes to defense market. I'm late, I'm catching up. Okay, you have here a quick view of the volume reduction for aircraft makers. So it's globally a drop of about 40%. So we are all delivering 40% less product in the aerospace industry that we were delivering last year. It's a 40% revenue drop. If you look at some worst quarter of this year, it's down for some company to 50, 60, 80%. So it's very difficult. It will generate consolidation movements, M&A, plant closure, maybe some company deaths. That's very likely, unfortunately, to happen. But we will definitely come out of that. Company are preparing to that, state are supporting, and in the end, it will help us being stronger when the crisis will be over. The big backlog of airlines will give a protection, but not that much, because most analysts consider that a certain part of the backlog is a false order backlog, which is more a protection of airlines that are not comfortable with having 10 years to have a new aircraft delivered, but that will not all place the orders. So let's see, it's a little too early to say. The aircraft OEM will compete with more efficient aircraft first in the segment of narrow body, that is dropping less. Narrow body are aircraft for short range routes. And as I said, you have here a graph that explains the scenario that we feel will be the one coming on. And in this way back to a bigger volume, it's important to keep in mind that industrial makers of aircraft were by pre-COVID time, delivering one aircraft out of two for replacement and one out of two for air travel growth. So if air travel growth is not here, it means potentially a volume twice less. But on the other side, fleet replacement to have more efficient aircraft, to have aircraft more sustainable, burning less fuel, will grow as an increasing demand from citizens, from countries. So this may compensate partly the additional capacity for air travel. Again, we'll see that. Trend for the future, aviation transport will push changes in the services industry around the airports. Some people are talking of aerotropolis evolutions, which is I would say an evolution of the geographic systems around an airport that is combining airport operations and urban areas. Let's see, there are big projects. Some have opened, like the new Istanbul airport in Dubai. They have also a big project. There are big projects coming with the UAM. Lilium has announced a project for an aerotropolis zone in Florida, US. This was some days ago. So they think of an aerotropolis urban organization around their Lilium Jet taxi future service. UAM is a new segment. Many operators, most of them will not leave, but several will be successful. They will address short distance range. They will address urban taxis. Let's see. It's a complex and very interesting future segment. Materials are in the evolution. We need lighter product. After efficient aluminum, the other alternative is composite material, plastic material, with a big disadvantage, which is that it is a fossil fuel product. We are using the petrochemical industry to produce this material. But on the other side, we are saving fuel during the product use. So again, there needs to be an end-to-end analysis to see what is the win compromise. Electrical propulsion will be a big trend. We'll discuss later. Cabin evolution with more connectivity to customize the passenger services even before flight. Cabin architecture may change with new project in the future. And I will stop with that because we could talk a lot. Very short video with the Airbus demonstrator of blended wing body concept. And because that was too long, I will have to cut the break. So let's say that we will start again at, after the break, we will start again at 2:35. So the video is 2 minutes, 2 minutes and a half. And after the video, 5 minutes break. I will keep on the line if you want a short chat with me. And we'll start with the course 2 at 2:35. Okay, so 5-minute break.
Thank you.
Situation will partly reshape the sector. Now, one comment. The images speak for themselves. When you drive a car, you are using a product 20 times your weight. This is 2 times worse as it was 40 years ago. Average car 40 years ago was 700 kilo. Now it's 1.4 tons. And definitely, I will give my answer. This is not efficient from engineers. Definitely not efficient. It has been pushed by marketing, and we need now to push in the other side. We have started. It is significant improvement, minus 2/3 with Twizy from Renault, minus 98 if you take your electric bicycle instead of a car. But I agree we miss some functions. The full service is not provided here. Anyway, we have invented and flown solar impulse, world tour without a single CO2 emission to operate the aircraft, to manufacture. There are batteries, there are solar cells, there are composites. So definitely there was CO2 to manufacture solar impulse. But Bertrand Piccard and his colleague flew around the globe without a single burn of fuel. So if we have been able to do that, I'm sure we'll be able to design and fly the 2030 low emission aircraft. I disagree with the zero emission. I think it's not feasible. Like Lavoisier said, rien ne se crée, tout se transforme. Nothing is created, everything is transformed. So we will need a little CO2, but we definitely need to reduce this by inventing the low CO2 emission aircraft. Okay, second course, thanks being back. Lean manufacturing in aerospace. First, few words on the starting point, then trying to tell you about how we did at Aerolia and Stelia Aerospace Company. Few examples and conclusion on what is key to deploy lean manufacturing in industrial company and in aerospace. Okay, sound is good. Everybody hear me? No issues? Please raise your hand if any problem. Okay?
No, it's good, it's good.
Okay. So starting point, lean started to appear in the 80s, but in fact come from Toyota system, and this come from Japan post-World War II. Country was very damaged. Material were not available. Workforce was reduced because of all the people who died. Infrastructure were down. Transportation system were down. And at that time, there was in Japan a mindset that what anybody could save in terms of labor minute, in terms of resource, in terms of machine time, in terms of whatever type of resource would help building back the country quicker. And this kind of DNA was well implemented in some company, and specifically in one, which was Toyota company, manufacturing weaving machines. So machines to make textile fabric. And it was in this company that started what was later called the Toyota system. And it was the Toyota system that inspired J.P. Womack in his book, The Machine That Changed the World. And this book was probably one of the big mindset change of the Western companies in the early 90s that started to implement these Toyota production system methods, but calling them lean manufacturing. So in a nutshell, was born in Japan, developed at Toyota in the Toyota production system and copied by the Western countries, first in US, then in Europe, and renamed lean manufacturing. Toyota production system, or Toyota system, is based on originally, I would say the DNA of the system is the scientific approach. That is to say, when you have to achieve a project, you have problems in front of you. You have issues to address. And when you have such, you need to work in four phases. You observe the issue, you question it, you make assumptions, hypotheses, you experiment, so you implement actions to see if your assumptions are the right one or not, and you check, you correct. Depending on the result of the action, based on your assumption, you continue in this direction or you change. So this is what I call the scientific approach. And this really developed in the Toyota system a kind of specific DNA that implies the person doing the job can be a worker in the shop floor, it can be a design engineer, it can be an accountant in an accounting department working on invoices. So it involves the person doing the job, it involves the supervision of a teacher, and potentially some support of experts. This was developed in Toyota company with two major pillars, the Toyota production system and the Toyota way. The Toyota production system is focusing on two big principles, just in time and Jidoka. We'll look at them later on. The Toyota way is more a way of behaving, a way of working between the people that is a lot based on the culture of respect and enabling people to experiment, enabling people to test, which is the country of penalties and fault culture. Okay, and it's when you enable people to test things that you grow a culture of improvement. I will not display the video, but you have the YouTube link because it's close to 8 minutes. I need to catch up my 8 minutes. It is an interesting 8-minute video that explains you about the Toyota production system using the example of Toyota forklift vehicle. So it's quite interesting. It's in English, so you will have no issue to understand. In aerospace, as said an hour ago, we don't have a century of serial industry culture like automotive. We are not in the world of producing T-Ford black cars like in Charlie Chaplin movie and repeating same activity every 10 seconds. Yet we are producing today at Airbus 2 A320 per day, 1 A350 per week, post-COVID. So it is still the world of small series. And to start understanding what this was, Boeing sent some executives in Japan about 20 years ago. And this first inspired Boeing in the reorganization of its Seattle assembly line of the 737 in Renton. And I will display a short video of this organization in a minute. And Boeing did not send Airbus did not send executive in Japan, but a little bit copying Boeing and inspired by the automotive company. Airbus CEO for a short period was Christian Streff, formerly CEO of Saint-Gobain and PSA after. And Christian Streff launched the lean manufacturing plan in 2006 at Airbus, first working on assembly line and enabling some plants to start having assembly line working along the takt time in a similar way as automotive line. Again, we will see that in the movie. I'm just completing the slide, so I don't lose your I don't lose your attention. So again, first step, looking at what the other ones were doing, the other sectors, and starting with management involvement. Second step, recruiting expertise. There were none inside the Airbus or the Boeing company. So there has been many recruitments with people having this experience at Airbus subsidiaries, including Aerolia. And I was in charge of creating in Aerolia the lean manufacturing department, which I was the head of. So I recruited many people between 2007 and 2010. And at that time, third point, we did a little bit like Boeing. We didn't send management to Japan, but we sent management of the different Aerolia and Stelia Aerospace management team to several companies. You have the name on the slide, in product not so far from aerospace fuselage sections, which is the product of Stelia Aerospace. Alstom, typically, the volumes of trains, the volumes of metros produced by Alstom are close in terms of monthly or weekly rates as aircraft. Caterpillar is more volume, but that was pretty interesting. And you can see that with years, we were visiting companies with bigger and bigger serial activity. Faurecia, Continental are typical automotive tier one supplier. Okay, short movie. It's more than 15-year-old, a little bit old-fashioned, but interesting to see how they reorganize the line. So it's the final assembly line for the 737. It was the 737 original model of the MAX. So it's the hall where they assemble all the systems. So an empty aircraft is entering the hall without any system, just the structure. And it's an assembly line, moving line, like an automotive car line, but very slowly, couple of centimeters per minute, 2-3 centimeters per minute. You can see the small trolleys to deliver the single component and tools to assemble each and every system. You can see this aircraft slowly moving. The rate was about 2 aircraft per day at that time. So you need to imagine that one aircraft is taking the place of the previous one in about 8 hours, because the plant operating 16 hours per day in 2 shifts. You can see simple system to handle the engines that are manually operated, much more flexible than a crane would be. You don't see big machines, you see a lot of human. It's more flexible. Small assembly station on the side of the line to compensate variation of the workload from operator, because one aircraft is different to the next one. So operator workload may vary from one to one. You need to compensate that to keep the operator busy. Here you see the technical people helping the production to solve an issue. Alerts being given by the Andon system. The small light is called Ando. It means light in Japanese. And it is used to call technical people for help. The moving line has the benefit to pull the flow, and pull the flow force the organization to solve the issues, whether there are quality, technical, or delivery issues. Those need to be solved ahead of the line. Because if not, the line will be stopped, and you can easily understand that if you stop the line, you stop all the aircraft, and then you have a big nightmare. 5 seconds ago, you saw a small ticket. It's a combo card, which is a small paper card used to act as a Kanban. A Kanban is a full flow system. It's a tool to generate replenishment of the consumption of the good at one step of the process. So it's used, for example, to replace one component that has been consumed in a trolley because assembled on the aircraft. The card is sent back to the warehouse, and it's a signal for the logistic team to place a new component in the trolley and to send back the trolley on the line side for the next aircraft. Okay, moving on. How did we deploy lean manufacturing at Aerolia? After having recruited a couple of people, at the real start, we had a lot of our work, which was after explaining, after motivating, after supporting the understanding of managers, of team leaders, of why we were pushing these kinds of new way of working. And it's not easy. You can't achieve that in a day. You need to start by the population that is doing the job. So when you are working in a production hall, you need to start with the operators, the companion, as I use the name, the blue collars. And you first need to separate from these, I would say, caricatural images of automotive industry, of a Japanese way of working, because there's a kind of pride in the aerospace sector because of the highly skilled population and the product complexity. So trying to mimic, to mirror the example of automotive is not definitely the right one. So a way to raise interest, to raise motivation, is to start with waste. In all work area, there are always waste. Even all of us, when we do our work, you as a student, me as a professional, we waste time on different occasions for different reasons. And sometimes we just waste our time or our money because we didn't organize the job in the proper way. And the identification of these kinds of waste and the belief that organizing the work in a better way, with better condition, will enable to save time and or money is the start of an understanding of lean, okay? And it will generate performance increase, because by saving time and or money, we'll be able to produce more product or to sell more products or to gain more customers. But this performance increase will not come from, I would say, a faster way of working. The question is not to speed up. The question is not to run where you were walking. The question is to eliminate reason for being stopped in your walk, to eliminate reason for taking the wrong route during your walk. Then there was also a lot of discussion on around the change of the context. And in the present time of COVID, I would say this is even more important, because it's not only just a business change, it's a social change, it's an environmental change that we are having in front of us. So this is also helping people to say, okay, yes, I agree, things are changing around. I agree, there may be reason for us to question whether or not to change. And then last but not the least, a very important thing is that whenever you recruit people that are experienced on lean, the lean department is not the one who will make the change. The lean department, like a coach that is working with a sports team, it's not the coach that will change the way of playing football or tennis or whatever the sport team is after. The coach will propose tools, the coach will highlight things. And the lean manufacturing is a little bit playing as like a coach with the population of employees that we want to improve the work condition. So the very important thing is that appropriation of the waste identification, appropriation of what to improve in the way of working, in the work condition, comes from appropriation is at the worker. The idea must come from the worker. The implementation of the new method must involve the worker. Otherwise, you will never get the appropriation, you will never get the motivation, so that the employee, once you have changed the way of working, will agree to use this new way of working. We had a lot of training. We more or less trained the whole population with prior training at workers, at managers, at union leaders also. Aerospace industry at big companies is an industry where unions are very important, and they are one lever among others to support changes. So training them was important. We trained the different sites, including the one in low-cost country, like the site in Tunisia. And depending the population, the site, and the role, and the level, the training methods were different. There was some training specific for one tool of 10 minutes duration, and other trainings for head of plants of 2 weeks times. So this was really customized to the role of the different population. With years, the training tends to be more specific, shorter, and more used for specific purposes. The first years were aiming at growing adhesion, understanding, adhesion, culture. And after some years' time, so this was in 2013, the need was no more after the culture. The need was to build a system and to make some tools available to the right employee in the right context. So to support that, there was a lot of use of visual management. We'll see that after. And there was a lot of use of short training modules that are easy to use for a manager. Imagine you are working as a head of production. Your direct reports are team leaders who are managing operators. When you have a production line issue and the line is stopped for 30 minutes because of a machine breakdown, the team leader has potentially 10 operators and he needs to do something for the hour stop of the machine. So having possibility to do a short training with ready-to-use training modules, that was quite interesting. And this was regularly things that we were doing to benefit from some non-planned stop and in parallel to grow the experience and the competence of the production population. After training, we had an important emphasis on the identification of the opportunities in our plants. And this we made through several exercises. One was value stream mapping, which is a tool enabling to map where are your big opportunities. I will explain next slide. Another one was to use waste identification. A third one, very interesting, is 5S, which is very simple, but it helps a lot, and it's a very accessible tool. Pull flow system is also something that we worked around, and visual management. So now I'll spend a few minutes explaining those 5 tools. Value stream mapping. This is an exercise that you are performing with a team of several functions that are representative of all competence of a plant area. So typically, if you consider a product line that goes from end to end throughout a workshop, throughout a shop floor, you will, with the team, physically walk around the product flow from the warehouse of raw material through each station of the manufacturing line and out with the finished product warehouse. And at each and every step where you will see product, you will question what are the inputs, the outputs, and the performance of the product. And you will also collect all issues that you have been seeing. It can be quality issues, it can be whatever things is questioning the team. And that's why it's good to have a team, and a team with different functions, because all the team members will see different things. And you capture all this with a certain methodology. You put that on a large panel. You have the picture of the one we did on the A380 nose fuselage section. And with this, if you perform that on all the product line throughout the plants, you can at the end compare the different areas of issues and their importance, because you have all the data around input and outputs. So you have the data of volumes, lead times, cycles, labor times, machine times. So you can categorize, and in the end, have the prior project emerge as the project with the biggest potential of waste reduction. Added value culture. Added value, the most interesting definition is the following. The added value is what the customer agrees to pay for. The added value is what the customer would agree to pay for. On the slide, you have this example of the pizza, and you can easily understand that if you have 2 pizza trucks and you see one with an open oven for 10 minutes, tomato cream on the floor, and the cooker spending time to clean, while another one is making the pizza, you'd rather go to the other truck, which is clean, saving energy, good packaging, no discussion. So generally speaking, focusing on added value is an important thing to identify the waste. Having said that, when you walk around the plant, difficult to say that it's easy to see what is added value and what is not. So practically speaking, to see what is non-added value, we'll need to look for waste. And there are 7 categories of waste in the industrial segment: inventory, waiting of products, defects, overproduction, motion, transportation, and overprocessing. Inventory, because the bigger your inventory is, the more you have cash issues from money you spent to pay your supplier and non-recovered invoice for the product you have not yet shipped and sold. Waiting, because when you have product weight, between 2 machines, is the same issue as inventory. Defects, because you spend money and time and expertise and cash in product that you will not sell. Overproduction, because you may have obsolete product that you will have to throw away. motion, because you use high-skilled workforce to move product, and moving a product has never added value to the product itself. Adding value means adding function to a product or material. Transportation, because the same than motion, but on top of loss of workforce, you lose the cost and you burn energy of a transportation beam. And overprocessing, because overprocessing is even worse than overproduction. It means that you are having too many manufacturing operations on your manufacturing line. 5S. 5S is 5 words in Japanese that means, sorry, it's in French. In Japanese, seiri, seiso, seiton, seiketsu, shitsuke. I'm not a Japanese speaker. Apologies if one of you speak Japanese. In English, débarrasser, to eliminate, tie up, clean, standardize, and make durable. So these 5 steps are used to improve the organization and the cleanliness of the work environment. And it's an easy tool that is usually one of the first that is deployed in companies that are deploying lean manufacturing. In Aerospace at that time, we decided to play with it, and we deployed these 5S using an audit method in parallel between office departments and production departments. And to make it more, let's say, fun and more, I would say, one team spirit, we had the office people act as auditors of the production sectors, and the production team leaders act as auditors of the office areas. So example, a production team leader of the machining department may have been an auditor of the office from the quality manager, or an auditor from the laboratory office. And we did that on a monthly routine with an audit provided by the auditors in the production halls in the office of a white-collar population. And every month we were scoring each sector with a small ceremony to share with the different auditors and the management the scoring, the best score, the best improver, and a little coffee and speeches from the head of plant. And even though it can seem simple and a little, I would say, a little like a game, it helped quite a bit in the mindset change. Pulled flow and takt time. Pulled flow is the planification method for manufacturing where the production order is started thanks to, I would say, thanks to a signal that comes from the customer consumption. So it means that production launch will be done to replenish the consumption of the manufactured product. It's a little bit like in the old times when you had milk delivered at your grandfathers or grandfathers. They were placing the empty milk bottle, glass bottle, at the entrance door of the house, and this was the signal for the milk run with his truck to give a milk bottle. Okay, and pull flow system is this kind of system. When the customer has consumed the product, he sends a signal to the supplier, and this signal is launching the production order. And by extension, we can apply also this principle of flow to logistic and supply chain system. A pulled system is a manufacturing planification that is not considering the customer consumption. The plant is deciding to produce, is pushing the production order, ignoring what happened on the consumption side. So typically, most garments industries are producing in pull system. They are preparing the season for shirts, for t-shirts, trousers, whatever, and they are pushing assumed volume. This will be manufactured in textile company, be sent to markets, and pushed for sale. Okay, so a pull system is not that. It's a system where you replenish the consumption. Automotive is fully in pull system, or mostly in pull system at all industrial players now. Aerospace is coming to it. And the most, I would say, advanced system where for pull flow is to pull flow using the takt time. It's a Japanese word, it's a German word, takt, and the takt time is the time frame between the market consumption of two products. So if you consider yourself like Boeing 20 years ago, in the video I shared, Boeing was selling 2 B737 by day to airlines. The best organization in pull flow system for Boeing was to be able to produce 2 B737 per day, so at the same pace of the sales. And ideally, it was to produce those two in the right order, and ideally the day before the sale. So practically it's not exactly that, because between the exit of the manufacturing hall that you've seen and the delivery to the airline, you have the test, the flight test. So this is taking a couple of weeks. But this organization is exactly a pull flow organization with one piece flow streamline operating with the time. Visual management. Visual management are tools that enable any employee, the word any is important, not only the experienced one, so any company, any employee, to have the capability to know what he needs to do according to his job on a daily basis. You are a worker, you work on this production line. If your company is a benchmark for visual management, when you have a part in the end, you will know where to put it. When the forklift is delivering some material to the line, the forklift driver will know where to place it. Even though it's a new forklift driver, he's been recruited the day before, he doesn't know the line, he will see a sign in the plant that will send him right to the line. On the line side, he will see a place where to deliver his pallet of material. You are quality technicians, your desk is beside this line. You want to know whether there is a problem. It's the first day of your work. If the company is a benchmark plant for visual management, you will have a screen that will present the line performance, and you will have under system, small lights like that will tell you if there's a problem, and if any, will indicate on which machine there is a problem. You will be able to visually see the performance of the day before with action plan. You will be able to see where are the safety risks with floor grounds marking. You will be able to see where you are authorized to walk and where you are not. All this just by looking, without the need to read a book, to follow a training or whatever. And although it seems maybe I would say surprising what I say, if you look around yourself and you keep this in mind when you walk in a city, you will see that the different cities have different level of visual management. Typically, if you are one day in Japan and you are in a big city like Tokyo, Japanese cities are very advanced on visual management. One of us could say it's a little bit too much, maybe too much noise or too much light or too much color. But on the other hand, I had a colleague that told me when I was in Japan, I had a 6-year-old kid, and the second day the teacher told me, you don't need to bring your kids to the house, to the school by car. You can drop him at the ground of your building. There's a subway station. He will know how to go to the school. And he said to me, they were right. All the signals and all the organization and all the visual things are so easy that there's no difficulty. Okay, I'm exaggerating a little bit with the 6-year-old. This was more for the, let's say, the risk. But generally speaking, Japan City are very advanced on visual management to enable people to find what they need, to understand what they need when they are in the city. And inside a plant, it's a little bit like that. You have people with fairly different understanding, experience, know-how. The difference between an operator and a visitor, for instance, is huge. And you can't take a visitor and spend 1 hour to explain what he can do, what he can't do when he visits the plant. Indicator. Why do we need indicator in a company? We need indicator and we need to have them visual because visual indicator is a way to identify some situation that is not in line with the expectation. Some measure, some product, some behavior that is not according to the standard, according to what it should be. And this is always changing with time. You observe a production line, products are fine, are confirmed, and an hour later, all the products are not confirmed. There has been an issue, it has been introduced in the last hour, and there has been a growing deviation. Changing example, safety. You walk around the shop floor, respect of safety rules, where to walk and where not to walk are strictly respected. And a year later, you walk back in the same production hall, nobody respecting anything. There has been a deviation in between. It has come progressively. Why haven't we been able to identify the deviation at the start? Because if we do so, the resolution is much easier. The longer you wait before identification of a deviation, the more it will be difficult to be back to the standard. To measure, we use indicator to measure in a company, in an industrial company, we use indicator to measure the deviation, to raise the question, to identify the cause, and I assume to support ideas for action and for improvement of the situation. So the indicator shall be designed according to a 3-step working methodology. That is, I observe, I understand, and I act. I am back again to the scientific methods that I explained in the introduction. You remember the Toyota way. So first you observe. What you observe first is where it happened. So if you are working on a production topic, on a production issue, you are not in an office. You are not in a central design office. You are on the shop floor looking at what is happening. And you look at the facts. You don't look at what people say. You don't read what people say. You don't listen to what people tell you. You look. Then you try to understand, and you will see some cause. And you will start to prioritize the cause. And then you will start, based on the cause, by doing assumption to propose solutions to attack the cause. And what are the topics on which to measure in an industrial company? The topics are the major issues, the major problem, the major deviations. They are after EHS incidents or accidents, environmental health and safety, quality, scrap concessions, customer complaint, customer returns, cost, labor cost, machine cost, delay, late deliveries, too high inventories, and also people. Wrong communication, lack of motivation, absenteeism. All these are potential areas where, as long as the company is able to identify deviation from a normal state, from a wished state, then the company is in better position to solve the problem and to drive improvement, because improvement is always after solving problems. The indicator itself need to be simple, need to be visual, easy to understand, needs to be smart, that is specific. It's not a global indicator that says many things. It says one thing. It is easy to measure. It is assignable, so you know who is responsible, which area, which perimeter. It needs to be relevant. It's stupid to measure 30 things if only 3 are important. And of course, it needs to be time-based. And it's very important when you are after indicator to separate what is the KPI with the rest. There are many indicators. It's infinite. There are indicators of activities, indicators of problems, experiments, revenues, salaries, people, thousands, and you will always see many. KPI are key performance indicators. So what distinguishes them from indicator is that first, they are after performance. An indicator of activity, like how many people in the company, or like revenue, is not an indicator of performance. Level of revenue is not performance. You can have very big revenue. If you lose money, you're not a performance company. If your profit is 2% versus another company making twice less revenue, but that has a 20% profit, this company is making 10 times your EBIT in percentage, and in value, this company is making 5 times more. So performance is not all metrics. And third, we are talking of key performance. All performance are not key in the company. You can't follow 20 key performance in a plant. It's too much. I like to say that human mindset is fine to monitor things that are not more than the fingers we have. So when you have more than 10 people as direct reports, it starts to be difficult. When you have more than 10 KPIs, it starts to be difficult. Why 10? Because a week is 10 half days. A month is 20 days. So keep that in mind. It's very important. So whenever someone tells you about an indicator, first question that you should ask for yourself is it just an indicator, a basic indicator, or is it a KPI? And unfortunately, in many companies, many people are using KPI for indicators, which is just stupid. So a KPI should answer first to the 4 questions of performance management. The 4 questions are where we are versus the target. Okay, so what is the preset measure versus the target measure? Second question, what is the prior cause, the Pareto cause, the 80-20? I don't care about the minor cause. I care about the major ones. The cause of this gap, the gap between present and expected value. Third question, what are the actions that we are having against those causes? We want to stop the cause, so we need to have action to kill the cause or to reduce them. And fourth question that the KPI needs to answer is the action that we have implemented. Are they giving the expected result? Now that they are done, was it the right action? Do we have the result? which means is the cause killed? Because if we took the wrong action, even though we have implemented, the cause is still here. Second important thing for a KPI, to enable the management do his job. The manager is always busy. The manager is having an agenda with a lot of things. So if the KPI is not designed in an efficient way, manager will not use it. It's as simple as that. When it is too complex, it's taking too much time, and manager hasn't got time to be spent understanding a document. So the document must bring very easily the different information of the item 1 above on this slide. And bringing this efficiently means bringing the information of the sub-perimeter. Example, we are talking of performance inside Airbus Group. So this KPI is Airbus helicopter, AIH, or it is Airbus Iliescas plant in Airbus commercial plane, or it is Hexcel plant in Dagneux, close to Lyon, inside Hexcel Group. So the perimeter is key. And also the cause of the performance needs to be visible with different perspectives. A technical one, the kind of cause, a customer one, the market cause, or a company one, the internal cause. I explain. Let's imagine that Hexcel has delivered a composite material to Airbus commercial Spanish plant in Illescas. It's a plant producing the wing of A350, wing panel, 36-meter long panel. So you can imagine the size of the plant, the size of the machines. We have delivered non-quality composite prepreg material. Let's say we have delivered 20,000 square meters of composite layout material, and there are 2,000 square meters which have weaving defects. If I just say that with a graph, then and I say to my manager, we have this customer return from Airbus Spain. No, sorry, back to my explanation. Let's assume I say we have 10% of customer return from Airbus. Okay, I don't mention the cause. Okay, then I will say we have 10% of customer return from Airbus in Spain, and this affects our quality performance by 2% because we have other customers. Okay, this is the cause of 2% of drop in our quality performance, and it is due because of the wrong delivery in Illescas. But I don't know about the technical cause. So I would need to have the understanding of what is the cause of this defect in the weaving. What is the technical reason for having delivered 10% of the square meter with defect? But if I was the vice president operation of Excel, that's an interesting information what I heard. But I would be interested to know where is the mistake in Hexcel Group. Hexcel Group is 24 plants. I don't know where the weaving was done. And my mission is to solve the machine cause of the wrong weaving. So if I want to do my job as vice president operation, I need to know this quality problem at Airbus Illescas, from which of my weaving plant it comes from. Because I need to place this topic as a key agenda item between me and my direct report, which is the head of Hexcel for this plant. Okay, so this is typically the kind of information that should go along with an efficient KPI. And then, as a conclusion, if you want the global KPI to be very quickly giving all those information, you need to concentrate on format that could be like this one. It's an example inherited from Ford Motor Company. Ford used to name this quality operating system. You imagine they call this A4 document, this Excel document, with the word system. Why? It's because it answers my 4 questions. What is the present situation versus the expectation? These are the monthly performance, and the target is here. So you can see over the last 12 months how you perform against the target. And you can also see in the rear mirror the last 4 years, which is of pretty interest. Because whenever you are here down versus the previous months, okay, you still see that it's still much better than the previous months before, okay? Second, you answer about the Pareto. What is the cause of 95% against 100% here? You have the reason here. Third, against this cause, you have action plan that are here to say, okay, because this cause explain my 5% underperformance, I am trying to fight with this action. And then with this graph, you are following for the different cause if the corresponding increase in your performance has been reached. And with this example, I will not go in detail. It's a personal example of stopping CO2 emissions for my personal commuting between home and work. But you can see that where the action has solved the issue, you see it because the problem is no more here, and the contribution to the underperformance is 0. So based on all these examples, I've spoken of 5S, of value stream mapping, of takt time, pole flow, 5S, KPIs. All these tools at a point of time, you need to package them in a system. Otherwise, it becomes difficult for the employee in the company to know where to have the answer when they have a problem of which tool to use and how to deploy the tool. So companies, after some time, are implementing system, and in 2013, we implemented in Aerolia what we call AES for Aerolia Excellence System, which was an organized structure for all the tools of the lean manufacturing way of working for Aerolia. Using this, we started to deploy ambitious workshops. One of them is 3X. I will explain later on in the example section. Okay, this is very small illustrations of the bricks of the different methodologies of the AES system, but I will not go in detail. And you see that you have tool bricks for each domain of the company: production control, logistics, safety, financial management. So it's not just after manufacturing. We start with the manufacturing, but obviously it goes much further than just the manufacturing scope. Okay, small Q&A to wake you up. No, small question, sorry, small MCQ. There are 6 questions on the slide. I will go one by one, leave you 30 seconds, and we'll have a quick discussion on what should be the right answer. Purpose is that once I'm finished, you take your personal, a personal reflection. You select yes or no for each question, and after the 30 seconds, I will give my view of the proper answer. And the interesting point is just for you to understand why yes or why no. So is land farmer common sense? Is this lean or not? Having a land farmer common sense, bon sens paysan for the French speakers, is this lean? Is it a kind of lean DNA, lean mindset or not? The definition of operating standard with an expert. So giving the expert the responsibility to define an operating standard. Is this, yes, a lean mindset, or no, it's not a lean mindset? Searching for the perfect solution, the solution that will solve 100% of the issue. Is this a lean mindset? Is this in line with lean manufacturing, yes or no? fully respecting the standards. There's a standard that says where you can walk, where you can't. Always, every day, respecting that, strictly speaking, whatever circumstances. Is this lean, yes or no? Considering that personal sanction should be used when employees make mistakes. Personal penalties when employees make mistakes. Is this lean, yes or no? And last but not the least, for those who listened, you have the answer. Assumptions, test, conclusion, hypothesis, test, conclusion. Is this lean, yes or no? Give you 30 seconds. And in the meantime, I will answer after the small video. Sorry, this one is in French. It's a funny illustration of 5S tool, standard, and people involvement, which is a pillar of lean manufacturing. Can you hear me?
Yes.
Yeah.
Yep. Okay, have you seen the 5S in the film? Can you hear me?
Yes.
Okay. Okay, anyway, let's take the questions. So land farmer, is that common sense? Land farmer common sense. Could we consider this is a lean mindset? Yes, it is more a lean mindset than the opposite, because it goes with elimination of waste. It goes with using all possible resources. So it's more lean mindset than the contrary. The definition of operating standard made by an expert. This is not lean. Operating standard needs to be defined with the operator, with the employee doing the job. It may be supported by an expert, but it is not the job of an expert to define the standard. Searching the perfect solution. No, it's not lean, because searching the perfect solution will take a lifetime, and in the meantime, there will be no improvement. Lean is continuous improvement, so you'd better take a 60% improvement that you can achieve in short time, and later think of additional 60 and 60 and 60, rather than looking for years to improve of 100%. The full respect of standard. This is lean. In any circumstances, no one should not respect the standard. And one standard may be improved. So if there's something that you see in a standard that is not the best way of working, you may propose to change the standard. You may lead a group of employees working on a better standard. But until the time the new standard is implemented, there is a need for a strict respect of the standard. Item 5, personal sanction. This is definitely not according to the lean mindset. If you take personal sanction for employee mistake, you will forbid your team to test when they have ideas, because you will set up a culture where mistake is not accepted, where failure is not accepted. And the scientific method is, of course, in the lean mindset. Okay, now a few examples. The first one was on A320 assembly line for the window frame of the cockpit of the A320 aircraft. The lean manufacturing project was using 4 workshops, one looking after just-in-time principle, and 3 looking at auto quality, we'll see, port flow system, and Genback cannery. Auto quality means autonomy of the production team to work after problem resolution. Port flow I already explained, and Genback cannery is a tool for team leader to better manage their team. The target was to streamline the process and make it visual, to implement pull flow, to reduce the workload, to balance it between the different operators in a more equal manner, to enable operators to stop the line when problem, to standardize the task, and to use visual management for problem. We were able to save 250 square meters of the building, and this was used for future implementation of a 350 line instead of investing in a new building. So the head of plant was pleased to save an extension of the building of 250 square meters. We could improve the productivity of 11%. There was 20 workers or 21 it was 19 workers working in the cell, and we could make 3 workers free after the workshop, and the 2 workers could be that were, I would say, no more needed, have been transferred to the new A350 lines instead of recruiting new workers. And also we saved 35% of stock and work in progress. There used to be 20 cockpit kits of frames, so 20 aircraft kits in the line, and after the workshop there was only 40. You can see here images of the window frames. So this is from the external of the aircraft. The pilots are inside. So this is a lateral left frame, lateral rear left, central left, and the frames are junctioned all together on these kinds of jigs. You see here the lights, the tricolor lights to raise the problem. You have the visual information for all the workstations, so a newcomer know immediately where is one station if he needs to go to the station. You see that the flow is just in line, one station delivering to the next station. You have here a simple plastic card pull flow system using Kanban principle and a leveling tool, Heijunka box, will not explain, it will take too long, that enable to level the production to the takt time to ensure that this line was always producing 2 aircraft per day. That was the rate at that time. And this is the logistic kit to deliver the 2 aircraft for the next customer. You have here the visual management for the safety, quality, delivery, cost, and people indicator of the line with the small actions to solve the daily issues. And you have here the work balance for the operators that enable the team leader to visually see if one operator is ahead or behind schedule. And when the case, the operator are moving from one station to another, helping to balance the workload and to achieve their aircraft on time. Second example, setup of a new plant in United Arab Emirates. Aerolia had gained a market of engineering transfer to support the emergence of a complete new plant in the desert close to Abu Dhabi. And this plant was given thanks to compensation market, which I explained an hour ago. Abu Dhabi Etihad company had bought a lot of A330, and they had negotiated that against this big sale for Airbus, Airbus would give aerospace industrial activity to the Emirates. So Airbus had the burden or had the job to set up a plant and to transfer some activity for the UAE to gain this activity of Tier 1 aerostructure supply. The target was to define the complete plant layout, the machines, all the detail of operating mode, of logistics supply chain mode, using the lean manufacturing experience and the milling experience of Aerolia, so that it would be a benchmark plant for the Abu Dhabi Emirates. The result, through a 3,000 man-hour engineering mission that was including my expatriation on site. No, I'm not in the 3,000 man-hour. I'm on top of the 3,000 man-hour. But the result was a big study where we delivered many, I would say, technical studies, recommendations, plant detailed setup plans so that the new company could operate with a performance in the range of +10 to +30% more efficiency, cost, work in progress, inventories versus the Aerolia one. You have here the image of the plants in 2011, 2013. It's an existing plant about halfway between Abu Dhabi and Dubai that is having a 22, that was having in 2014, $22 million revenue per year of sales to Airbus and Aerolia. It has grown bigger than that. And the most complex equipment was this machine, which is the size of a train wagon, 19 ton per machine, manufacturing 4 meters door frames in aluminum for the A320 market. You have here one of the several of the numerous drawings of how to install the plant that we delivered to the company. You have here detailed analysis of man-machine synchronization to minimize the cost of man aside the machine and to optimize the use of the machine with different proposals. You have here simple sketches of how to handle the product, principles of a Kanban system, takt time and machine allocation tables, auto quality matrix, so ways of working to drive the autonomy of operators on the shop floor. Big project. Last and third and last example, 3X factory of the future in Stelia Aerospace. This was probably the biggest project ever in Stelia on lean manufacturing. It was a massive shop floor engineering project to transform in a 3 years' time the complete assembly halls of Stelia Aerospace Melt location between Paris and Lille on the 4 program at that time, A380, 30, 50, and 20, to move from a multi-program techno-oriented in push mode to a single program customer-oriented pull mode system. Before, the organization was techno, so depending the technology, there was halls dedicated to technology that were manufacturing the corresponding pieces for the 4 program. After the change, there's 1 hall per program doing the entire scope of assembly operation of a single program, so aligned with a single customer at Airbus site, which will be which is the full assembly of the fuselage. And the target was to have this new factory compatible with the future evolution of rates, which were in 2030, 40, to increase up to 3 per day in A320. And it was the case, because last year rate of A320 was 60 per month, that's 3 per day. 380-50 per week, it was nearly the case. We were at 11 per month last year, so 11 or 10, so close to 3. And unfortunately, A380 never ramped up to 3. It stopped at 2.5. The result was a big change in the plant and a complete transformation of assembly principle, mainly for A320 and A350, with streamline flow, so 1-piece flow for the 2 programs. And for the A320, it was a moving line, so same principle as what you saw for the 737 20 years ago in Seattle, but this is in 2016, 2017, in Meaux for the fuselage section of the A320. I will not show you the whole video because some part of the video is just techno. I will directly go to the A320 moving line. It's a line moving at 2.5 centimeters per minute that was manufactured in 2017, about 55 cockpit sections and front fuselage sections per day, so 3.5 centimeters per minute. That was 1 section every 5 hours about, working 2 shifts per day.
Of course, it's accelerated. You can see the timing left top. This is the front fuselage, the lower part. The box is the box for the landing gear track, front landing gear track. This is the cockpit line, the rotating moving line. There are many supply chain tools using digital techniques to enable the supply of each and every component in the right time, in the right place. You see the unknown system. There are still simple visual management tools. Also using the digital mockup to simulate assembly. Augmented reality is also used to avoid the quality mistakes in the assembly of bracket. Okay, conclusion. The fundamentals in the aerospace industry. You hear me correctly?
Yes.
Yeah.
Yes.
Okay. So as a conclusion, as you understand now, it's a sector with a strong product identity, with a big priority on technical matters, engineering, technology, with a history of vertical management. So focus on the two key fundamentals. Focus on the fundamentals is very important. It's well adapted. The fundamentals are the basics of the Toyota system and are the workshop methodology. So the basics of the Toyota system is this small house that is usually named in the Toyota philosophy, the Kaizen house. So it's based on 3 principles, 7 concepts. On top of that, you set up your tools and system. All what I told you about, in theory and in Aerolia, are tools and methods. 5S, value stream mapping, pole flow, all this is tools and system. And depending your company, depending the market, you will put more lights on some, you will start with some or others. It depends. It's a toolbox. But this toolbox needs to be deployed on foundations. And the foundations are the 3 principles and the 7 concepts. The 3 principles are process and results. You will get the result because the process is in place. So you can call for results, you can claim, you can shout for results. You will not get result by shouting, you will get result, or by dream, you will get result by process. So building a strong process, as we saw with the pulled flow system, is bringing results in terms of supply chain performance. Global system. If you want to reduce the cost and you separate your different departments in the company, you will have issues. You must consider the operation as a global system and work around improvement of the operation with all the function, because some decisions may act in opposite direction, and you need to avoid that. And very important, you can't have the right people involvement. If you judge, if you blame people, you will not let the room to mistake, you will not let the room to failure, and you need to accept to do that. These are the 3 principles. It's key. If you don't have that robust, the company will not be a benchmark lean manufacturing company. I will not detail the system, the concept. I will let you see. There are easy to understand, and I'm sure you can read in books to know about that. We'll finish with the workshop. The workshop, sometimes called the Kaizen event, is key. Why? Because it's just a methodology to deploy the tools and to work around improvement on the Gemba being the place where the added value is created. So a shop floor is the Gemba place for a production plant. A design office is the Gemba place for a designer team. And a workshop is the methodology that is fast, that is based on observation and action, that is using the support of management, and that is taking place on the Gemba in a short time frame that forces people to act and to get results. This is key. We used it a lot in aerospace, and it has its room as a fundamental tool to deploy. So in a nutshell, we have launched the Lean with the 21st century in aerospace. Even though the sector is specific, we can use the key enablers, training involving the operators, not ignoring the unions, better involving them, acting upstream, long lead time, 8 years development. If you don't work on the upstream topics with the new product, you will not have the money to change the complete shop floor. And to deploy the Lean, the basic tools as like workshop and management support are very important. Digital will be used as a tool. It's not a strategy in itself. We will talk again in the December 17 course, but it can help and accelerate the mutation by giving more accessibility to the data for the customer, the design engineer, and the operator. That's finished for me. Thanks again for your attention. I hope it was of interest. And again, we'll meet Sophie. Yeah.
Yes. Thank you very much, Frédéric, for this presentation. So I was not able to join on time because I had a link, but I couldn't find it anymore at the moment of the beginning of your presentation. And then I was teaching at 1. So I couldn't come before, sorry. Okay, thank you very much to all the people in the class. Perhaps they would like to ask questions before leaving the room, I don't know. But thank you very much, Frédéric, for presenting all this. Thank you.
I'm available for questions, so those who have time will not spend 5 hours. But if there are questions for 30 minutes or an hour, I'm happy to.
Just a general question: will we get access to the slides?
I gave them to TBS 2 weeks ago, so.
Yes, I will put them online just after the lecture. Yes. Yes, they will be online just after. No problem.
Thank you. I just could not find it, so yeah.
Sophie, one question on that. I think I sent you a version with 2 slides per page, vertical format.
Yeah.
Because
a question is it worth enough, both in time of money and time, to implement Lean in let's say a small scale manufacturing? I mean, maybe employing, let's say, 10 to 50 employees.
Of course, there's no limitation in scope to apply Lean. Of course, if the company is small, you will not deploy as many tools as in a big company. You will select the tools that are the right way to work on the key issues that you will have identified in your scope. But yes.
So it's more about production management and not about the perfect Lean management in small factories, I guess.
Sorry, again, your question?
It would just be like a production management, like a normal one, more than a perfect Lean management in a smallest company.
Not necessarily. I would say, depending of the operating scope of the company, you will not use the same tools or the same number of tools. If the company is designing, producing, selling, you have a wider scope of operation than if the company, for example, is just producing, okay, with no design capability.